Hello everyone, this is Petko from GraphOps, and today we'll be looking at a Subgraph Radio demo slash workshop. First, we're going to talk about what Subgraph Radio is, and then we're going to look at 4 different ways of running it. First, we're going to take a look at running it as part of a Docker Compost setup, and we will use the stake split stack for that, but it will work for whatever Docker Compost setup you have. Then we'll see how to run the radio as a Docker image, then as a standalone binary, and finally how you can build and run it from source. After that, we'll see how you can set up a Grafana dashboard to monitor the state of the radio, because Subgraph Radio exposes Prometheus metrics on a given port. Then we'll look at how you can utilize the built-in HTTP server that has a GraphQL endpoint in order to send GraphQL queries and get more insights on the radio state. And finally, we're going to take a look at POI divergence notifications. So we'll check out how to set those up and what they look like. Okay, so before we jump into the actual demo, let's talk about what the POI crosschecking feature of Subgraph Radio actually is. The POI crosschecking feature of Subgraph Radio is the first and main feature so far, and this is a high-level overview of what that actually is. So here in the middle, you see the Subgraph Radio that indexers are running locally. So it monitors subgraphs on the graph node, and then at a given interval, it sends the public POIs for those subgraphs off onto the GraphCast network in the form of GraphCast messages. And those messages basically include the public POI, but also other relevant metadata. Those messages get sent off onto the GraphCast network, and they are received by other participants in the network, so other indexers running Subgraph Radio. At the same time, the local radio receives messages from other indexers, and so it gets a view of all of the public POIs that are flowing through the network. And at another interval, it will compare the local POIs with the remote POIs that it has received. And this happens by comparing the local POI for a given subgraph on a given block to the consensus POI. Now, what is a consensus POI? Well, when the radio receives messages, it then saves all of the received POIs for a given subgraph on a given block, and it checks the stake of the senders of those messages, and then it takes one remote POI, which is the POI with the most stake tied to it. So that is considered to be the consensus POI. And then it compares the local POI with the consensus POI. And if there's a divergence, so if those two are different, it will send a notification if you've set up the notification system. If they're the same, then there's a match, and that's great. I also just want to point out that the consensus POI is the one with the most stake tied to it, but that is the aggregate stake. So if one indexer has more stake than everyone else, his POI is not going to be the consensus POI if there's another POI with a higher aggregate stake. So just wanted to make that clear. And then while all this is happening, a summary of all of this is being shown on the Grafana dashboard if you've set that up. Now that we've established that, we can jump straight to the live demo. So if you go to our docs page and you click on the GraphCast section and then scroll down to Subgraph Radio Introduction, you will see the different ways of running the radio that we spoke about in the beginning. We're going to start with running it as part of a Docker Compost stack, just because Subgraph Radio is included in the optional part of Stake Squid's Docker Compost stack. So we will just start with that one as it's the most straightforward. But essentially, whatever your Docker Compost setup is, you just have to add Subgraph Radio as another container and specify the required environment variables. And the environment variables you can find here in the basic configuration. And if you want to customize things more, you can go to the advanced configuration section and look at the environment variables there as well. So in our case, we're going with run as part of Stake Squid's Docker Compost setup. So we open one of the repos, mainnet or testnet, depending on where you want to run it. And then we go to getting started. And over here in the environment variables, you'll see that there's a whole section for Subgraph Radio. It's important to note that you don't need to provide any of these environment variables, because Subgraph Radio uses defaults, and by default, if you haven't provided a private key or mnemonic, it will take your operator seed phrase and it will sign and send messages using that. Of course, it's still very much recommended that you use a GraphCast ID wallet to add a layer of security. So if you want to learn more about what GraphCast ID is and how you can utilize that and use that instead of your indexer operator seed phrase, you can go to GraphCast SDK registry contract and read more about that. But for the sake of this demo, we're just going to use the operator seed phrase. So it will use defaults. If you want to check out what those defaults are, you can go to Compose Optional and actually see the container definition for Subgraph Radio. So these are the defaults that it uses if no environment variables are set up to override them. So of course you can override these environment variables in the .env file or override them directly in this file. So now let's look at how to actually start Subgraph Radio alongside the StakeSquid stack. Here in this node I have the essential stack running, and if I want to run Subgraph Radio alongside that, I would just do bash start all Subgraph Radio, and that will start the image. Then if we look at the logs, we can see that the HTTP server has started, the metrics server has started, we've loaded data from the state.json file. If you're running this for the first time, you won't have a state file yet. It will create one for you. And after that, we just have logs at a given interval to let us know, for instance, how many messages we've sent, how many subgraphs we are waiting to be synced to Chainhead before we can send public POIs for them, how many connected peers we have, and a lot of other useful information. Of course, it's much easier to get this information from the Grafana Dashboard, which is what we will going to be looking at next. So if you go to your Grafana Dashboard host page, if you're running this with StakeSquid Docker Compose, you will have the Grafana Dashboard already set up. If you're running Subgraph Radio in a different way, I will show you how you can set this up on your own, because we provide a dashboard configuration JSON in the repo. So if you want to do that, just skip to the relevant part of the video. But if you are running StakeSquid Stack, you will already have a GraphCast Subgraph Radio dashboard. This is what the dashboard looks like. And right off the bat, we can see how many subgraphs are matching and how many are divergent. And again, this goes back to what we talked in the beginning. So a match would mean that when a comparison has happened for a given subgraph on a given block, our local POI matched with the consensus POI. And divergent is for the ones that it didn't match. And the reason this metric is a gauge and not a counter is because rarely, but it can still happen that one subgraph, when you compare your local POI to the consensus POI for a given block, it might match, and then sometime later, at a later comparison, the POI might diverge, or you could not be synced to Chainhead. So that's why this is a gauge, and it can decrease and increase depending. We have some other useful logs like validated messages per minute, messages currently in the store, the total number of received messages since the radio was started. Then over here we have the number of gossiping peers per subgraph, which is important to actually know what is the pool of indexers that are sharing their POIs and that you are comparing your local POI with. Then we have function call stats, so you can see the frequency of some important functions like sending the POI message, processing a valid message, the times that you've compared POIs, and a lot more. Then we have the number of diverged subgraphs and how that has changed over time. And last but not least, the POI comparison results panel is probably the most important panel. So we're going to double click into it. But basically, this data is coming from the GraphQL endpoint, which we're going to take a deep dive into in a bit. But it shows the results at the time of the latest comparison. So this deployment has been checked at this block. The POIs have been compared, and these are the resulting ratios. Now, if there's just one number and a star, that means things are good, because wherever the star is, that means that there lies the consensus POI. So here we see that we've received POIs from two other indexers, and our POI is also in there. And since the free values are the same, that's why the subgraph for this block is matching, and that's why we have the number of the indexers and a star, which means that this is the total number of indexers with this POI, and we are a part of that consensus. And the same goes for the stake. This is the combined stake of the three indexers that have attested to this POI, and since our own stake is there, that's why we see a star. Now we scroll down a bit to try to find something that is divergent. Over here, you can see that it's one to one, which means that we have a local POI. We've received a different remote POI. That's why there's a divergence, and that is why here you would see the count, the number of indexers that have sent a different POI. This is basically the local indexer who, and we are here. The star is here because this is our own generated POI. And same goes for the stake. This is the stake of the indexer who has a different POI than us, and this is our stake. The star means that we are part of this value. And since the other stake is bigger, that is why our POI is divergent. And if you want to learn more about the Grafana dashboard, here under Subgraph Radio, there's a notifications and monitoring section. And there's a part that explains how to set up the Grafana dashboard and then how to read it, which basically includes the things that we talked about until now. But you can read in a bit more detail about the POI comparison results panel and how the results are formatted. Now, if we go back to the Grafana dashboard, oh, by the way, this is an interesting result. I'm glad it comes up now. So this means that there are in total 5 different POIs that we've received for the given subgraph and the given block, and one of them is different than the consensus POI, but we are in that consensus group. That's why we have 4 with a star, so 3 other indexers except us, plus us attest to the same POI, and then there's another indexer who attests to a different POI. But now, back to the point, all of the data in this panel here, plus this POI comparison overview panel, is coming from the radio's HTTP server that we mentioned earlier. So using the HTTP server, you can dig deeper into the radio state, and we're going to look at how to do that now. Over here in the Subgraph Radio section, there is a HTTP server page, which explains how to get started with the HTTP server. You just need to have set up a server host and server port environment variables, and the radio will spin up the server on the given host and port. The server has 2 endpoints, health for just general health status to confirm that the radio is up and running, and then /API/v1/GraphQL for the actual GraphQL server, and you can use that server to send the following queries in order to really dig into the radio state. Now, let's look at that in action. In order to access the GraphQL endpoint on the HTTP server on your radio, you would need to go to whatever you specified as a host and port, then /API/v1/GraphQL, and then use one of our queries. So I will demonstrate them one by one. The first one is the public POI messages, which will show all of the public POI messages that we've received from other indexers running the radio. As you can see, they are a lot, but I want to talk about the message structure a bit. So this is what the public POI messages look like. This is one message. It has a identifier, which is the deployment ID of the subgraph. Then it has a nonce to know when the message was sent. Then a signature, because every message is signed before it's sent, and then the graph account resolved from the signature. So And in this case, in the case of the public POI messages, the graph account is always the indexer address of the sender. So no matter if the sender used the GraphCast ID wallet to sign the message or a indexer operator address, the graph account will always be their on-chain indexer address. So this is just the metadata of the message, and then this is the actual message payload, which includes the identifier, which is again the subgraph hash, and the content, which is the actual public POI that has been shared. And what's cool about this is that you can filter by subgraph. So let's say we only want to get the public POI messages for this subgraph. We will do identifier and get only ones for this subgraph. And we can even be more specific. Let's just get the block number like that. And now we can filter both by subgraph and block. Okay, there we go. And we get only received messages for the given combination of subgraph and block. Now we can also query for local attestations. So let's look at how that looks like. It's mostly the same, but you get only the locally generated public POIs. And we can add filters again, like block or identifier. And this is what it looks like. And obviously it's a lot, especially if your radio has been running for a while, because all of that is saved in the state. But basically you get the subgraph, the block number, the public POI in the form of your own attestation, and that's it. Now, probably the most important query is actually the comparison results query, because that shows you the most recent comparison results for subgraph, and it lets you peek into divergences at a deeper level. Remember how we said that all of this data in the POI comparison results panel is coming from the HTTP server? That is true, but using the server you can get even more. So let's just see an example query. So we can get the comparison results like this, and we need to provide filters. So this could be the subgraph, it could be the block on which we want to see all of the comparison results, or we can filter by result type. So you can only see the diverged subgraphs or the matched subgraphs. And I think this example will work best if we actually find a diverging one like this one. So if we copy this subgraph hash over here, and here we see that the most recent comparison result for this subgraph is divergent. The comparison has happened at this block. Over here, you can see all of the attestations. So, well, first you see the local attestation, which is this, and then you see all of the attestations that that we've received. So there is just one of them, but there are two senders. And you can gather that from here. You can see that two indexers have sent a POI that is different from the one that we've generated. So here you can see what those senders are. And remember, this is always the indexer address. Doesn't matter how they've signed the message, whether it was through a GraphCast ID or with the indexer operator wallet. And here you see the stake weight of this POI, which is the combination of the stakes of these two senders. So this is just very useful to dissect divergences when they happen. And it also gives you a nice way of getting a aggregated view of what's going on. So let's say you want to see all of the subgraphs that have a result type divergent. Here's how you can do that, and then use this data to query something more. And I think that's it for the comparison results. Now, there's this upgrade intent messages, but we'll cover that in the subgraph upgrade precinct feature in one of the next videos. It's not relevant to the POI cross-checking feature. There's also comparison ratio, which includes stake ratio, but this query is what powers these two columns, the count ratio and the stake ratio. So you wouldn't necessarily have to manually send them to the server when you can look at them here. I mean, only if you're doing some sort of automated solution, or you're already digging in the server and just want to see those as well, but I don't think we need to show them now. Now, before we move on to the other ways of running Subgraph Radio, I want to talk a bit about notifications, because they're a very important piece of all of this, because you would want to get notified as soon as the radio detects a divergence. Or if you have a lot of subgraphs and don't prefer that to be that spammy, you can also configure it. We allow a lot of configuration options for our notifications. So if you go here again in Subgraph Radio and then in notifications and monitoring, you can read about our notification system. But just at a high level, we support three notification modes. So live, periodic update, and periodic report. So the live one would send a notification as soon as it finds a divergence. The periodic update will send a notification on a specified interval, default being 24 hours, and it will contain any updates to the comparison results that have happened since the previous notifications. So if there are no updates, if the state of the comparisons is the same, it will not send a notification. And then periodic report is again sending it on a specific interval, default being 24 hours, with a summary of the total subgraphs being cross-checked, number of matched subgraphs, number of diverged subgraphs, and a list of the diverged subgraphs, as well as the blocks where the divergence was caught. So it will send a notification every time when that interval hits. Now, in order for notifications to work at all, you would need to have set up at least one of the three possible integrations. So we have Discord, Slack, and Telegram. And depending on whatever you want to use, you should set the relevant configuration option. You can check those out in the advanced configuration. Then once you do that, if you don't set a notification mode and notification interval, the default option is live. So if you just set up a integration with one of those messaging apps, the notification mode will be live. If you want to override that, you will set a different one using the notification mode configuration variable and notification interval if you want to change the interval rather than use the default 24-hour one. I also want to show you what the different notification message types look like. So this one is live. So the moment it compared POIs and found divergences, like this block, directly sends a message of which deployments are divergent. Periodic update messages look the same, just they're going to have more messages and for more blocks, but essentially the format is the same. The different one is the periodic report one, which looks like this. So it tells you how many subgraphs you are actively cross-checking, how many of them are matching, how many are divergent, and then a list of what the subgraphs are and which block was the comparison where they diverged. Now that we've seen all that, I want to talk a bit about the different ways of running Subgraph Radio before we actually look at them in action. So how would you choose which way to run Subgraph Radio? Basically, however fits best with the rest of your stack. So if your stack is in the same kind of Docker network and all, you can use Subgraph Radio straight in your Docker Compost setup. Of course, if you're using Statequid stack, it's already included. If you have a kind of a more custom stack and your components are in different places and you want to fit that with the rest of your components, you can run it as a standalone Docker image. If you're not using Docker, or if you don't want to use Subgraph Radio as a Docker container, you can use our pre-built binaries. So we have pre-built binaries for macOS and Ubuntu. And of course, if you want to have full control and you want to tweak the radio, you can build and run it from source. You're going to need to install a lot of things, but of course, that's only if you would need to change anything, or if you want to compile a binary that isn't included in our pre-configured options. So let's get straight into them. We're going to start with how you can run Subgraph Radio as a standalone Docker image. So if you go here, so you would first need to pull the image. So I'm just going to copy this and go to my terminal, pull the image. While we wait for that, I've just constructed a command with the relevant values. And if you want to see what environment variables you can pass in, so these are basically the required ones. So even if you go here, you can check. So in the basic configuration, you see the required environment variables, and then if you go to advanced configuration, you can read about all of the different things you can configure on top. These are all optional, but I urge you to take a look at them as well. Let's see if that's downloaded. It is. So now if I run this, and let me just quickly go through the variables. So we're running this. So the GraphCast network is testnet. And this is just the GraphCast network defines how messages are being routed within the GraphCast network. So usually when you're running a testnet indexer, you would specify the GraphCast network as also a testnet, and the same thing with a mainnet environment. You would specify the GraphCast network as mainnet. You could also send testnet data, and you can use a testnet indexer to send messages on the using the mainnet GraphCast network, but your messages are most likely not going to get validated by 99% of the other participants, because because GraphCast validates incoming messages using the network subgraph and the registry subgraphs that you've provided. So if you receive a message from a testnet indexer, but your network subgraph is a mainnet network subgraph, then that message isn't going to get validated. So that's why here I'm setting the testnet GraphCast network, and I also have the Goerli registry and network subgraph endpoints. And if you want to see more about these endpoints, here in the registry contract section of our docs, over here we have URLs for network subgraph endpoints and registry subgraph endpoint. Then after these three, we have the private key, and obviously this is not an address that has anything in it. And then we have the graph node status endpoint. This is important. So if your graph node is running in Docker, you would obviously specify the URL where that's running. But in my case, I want to run Subgraph Radio as a Docker container, but graph node is running locally on this machine. That's why I would do host docker internal. Then Rust log, you can specify the most important parts here are Subgraph Radio and GraphCast SDK. And again, in the docs, you can see the different log options, but info is the default. And then you provide the indexer address. So now if we run this command, it should properly start everything up. And it started. So now let's look at the binary option. So if we go here, as we mentioned, we provide Ubuntu and macOS binaries. So if you go to our release page, you will notice that for every release, we have assets, which include the macOS binary and the Ubuntu binary. So you would download one of those. The machine I'm using right now to test this is a Mac, so I will download the macOS binary. And once you've downloaded the binary, basically just do the same thing. You evoke the binary with the configuration arguments that you want to use, and it starts up. That is how you would run Subgraph Radio as a native application. And lastly, if for some reason you need to build and run Subgraph Radio locally, you would need to install a bunch of prerequisites, then go to the repo and clone it. So let's just do that real quick. So you would clone the Subgraph Radio repository, cd into it, and do cargo run -- release. Of course, you would need to populate the environment variables that you want to use in a .env file for this to work. And when you have those variables, it's just as easy as cargo run -- release. But you need to specify that it's the Subgraph Radio package. It's going to take a while to compile, but once it compiles, it should run without issues. There we go. When it starts up, we should see similar logs to the ones that we did on the with the Docker Compost setup. Now let's look at the scenario where you don't have Subgraph Radio running as part of Stake Squid's Docker Compose stack, and you want to set up your Grafana dashboard, which is obviously very, very useful for monitoring, as we've already seen. So if you go to the advanced configuration, you see that we have a metrics host and metrics port. So if the metrics host and port are set up, then Subgraph Radio will expose Prometheus metrics, which then you can scrape. So if you point your Prometheus server to the metrics host and metrics port, it will scrape these metrics. And I want to show you how you can do that. I have a very basic Prometheus setup, so it's just set up so that it listens to metrics on a given host and port, which is where Subgraph Radio is exposing them. So if I run this, then the local Prometheus server is starting to scrape the metrics coming from Subgraph Radio. Now that our local Prometheus server is scraping the metrics that are exposed from Subgraph Radio, we can configure Grafana to use Prometheus as a data source, but we'll also need to configure it to use the GraphQL endpoint on the HTTP server as a data source if we want to use the Grafana dashboard that's provided in the Subgraph Radio repo. So before we do that, let me just show you. Here on Subgraph Radio, we have a grafana.json, which is basically the JSON configuration for our dashboard. So if you take this and you go to dashboards, then you can do import. You can paste the JSON here, load the JSON, and then it's going to ask us for two data sources. So a Prometheus data source and a GraphQL data source. Now, let's take a look at the data sources that we have. And I'm assuming that you have a Prometheus data source, or if you don't, it's pretty straightforward. So it's a Prometheus data source that points to wherever your Prometheus server lives. In my case, it's just localhost 1990. And the Prometheus server itself, again, scrapes the metrics exposed from Subgraph Radio. So that one's easy. The Prometheus one is easy. Now, the GraphQL one, it's a bit more tricky because Grafana doesn't have a GraphQL data source plugin by default. So in your local Grafana instance, you have to go to plugins. Then you see the plugins, and you can search the plugins, and you search for GraphQL. There's the GraphQL data source. So you click that, you install it. And once you have that, we have the GraphQL data source plugin, but we still haven't created the GraphQL data source itself. So we should go to data sources, add new data source. It's a GraphQL data source. And now you need to point it to wherever you've set up your HTTP server that lives in Subgraph Radio. And in my case, it's this link here. This is the host where I have my Subgraph Radio running, and this is the port that I've configured. So if we go back to the docs, you can configure where this HTTP server is running on. Here in the advanced configuration, you can specify a few ports, and one of them is server port. So server host and server port. This is how you specify where this HTTP server runs, but wherever you've set it up to run, you do that host and port, and then /API/v1/GraphQL. So this should be enough actually. If I save that, looks like it's working. Now if we go back here to the window where we're importing the Subgraph Radio dashboard, here for the GraphQL data source, we need to select our data source. It still can't find it, so maybe we can import it again. So if I copy over the JSON, import that, load. Prometheus is the Prometheus one, and still can't find the data source. This is interesting. If we check data sources, okay, so we do have it. So not sure why we can't find it here. Let's restart this, copy this over, load. There we go, GraphQL data source, the one that we just created. Select that, select the Prometheus one, and we import. And that's how you would import the Subgraph Radio Grafana dashboard if you're not using Subgraph Radio as part of Stakes with Docker Compost Stack. And that concludes the demo. Thank you so much for being here today and going through this with me. If you want to learn more about GraphCast and Subgraph Radio, here are the links to the relevant docs pages and also the repository of Subgraph Radio. We also have a request for feedback issue, and we'll be very, very happy if you submit all of your questions or issues or any feedback on the development of Subgraph Radio. Also, feel free to open up new GitHub issues on our repositories. Reach out to us on Discord, in the GraphCast channel, in the Graph Discord. Reach out to us on X, formerly Twitter. We're just very excited to have you on as users, because the more users there are of Subgraph Radio, the more the data is valuable. So thank you again very much, and I'll see you in the next one.